Out here, where the last photons shimmer like embers on a dying wind, the universe seems to whisper. Galaxies, stretched thin by time, dissolve into darkness. Their spiral arms, once teeming with fire, now drift towards silence. The edge of visibility, the cosmic horizon, glows faintly, not with stars, but with memory. Every telescope, no matter how far it reaches, peers only into the past, never beyond it. There is a place, not in distance, but in depth, where the known ends and the unknowable begins. A frontier not marked by stars, but by questions. What lies beyond the light we can no longer catch? What breathes on the other side of time's vanishing point? The observable universe is a sphere, 93 billion light-years across, stitched together by ancient light, wrapped in expanding space. But it is not the universe. It is only what can be seen, a snow globe of galaxies inside an ever-swelling ocean. And that ocean may be infinite, or not. It may curve gently upon itself like a snake eating its tail, or it may extend forever, with bubbles of reality flickering into being, each one sealed from the others, each one a separate story. Cosmic inflation, a burst of unimaginable expansion at the dawn of time, suggests that our universe may not be alone, that we are a bubble, born from a quantum spark, growing in a vast, cold sea of other bubbles, each one governed by its own physics, its own story, its own stars. And if that is true, then everything we know, the galaxies, the laws of nature, even time, may be local conditions in a much larger, much stranger landscape. Maybe the cosmos we call home is not the whole. Maybe it is only a window, and something vast is watching through the glass. The question is not where we are, but what else is out there. In the late 1970s, the universe was still a puzzle with pieces that didn't quite fit. The Big Bang Theory had become the accepted narrative, a beginning marked by fire and density. But beneath its surface, cracks had begun to form. The deeper cosmologists looked, the more anomalies surfaced, like fossils in the dust of creation. The universe, it seemed, was too smooth. Wherever one looked, across opposite sides of the sky, the temperature of the cosmic microwave background was nearly identical. But those regions had never been in contact. There hadn't been enough time since the Big Bang for light or information to travel between them. This was the horizon problem. How could such distant parts of space be so eerily synchronized? Then there was the flatness problem. According to Einstein's general relativity, the shape of the universe depends on its density. Yet, observations showed a universe so precisely balanced, so flat, that even the smallest deviation in the early moments of existence should have sent it collapsing back inward or ballooning into nothingness. But it hadn't. Something had held the cosmic scales in perfect tension. In quiet corners of MIT, a young theoretical physicist named Alan Guth was thinking about the early universe. Not the fireball, but the moments before it, where physics itself teetered on the edge of comprehension. He was searching for a mechanism that could explain the anomalies, something bold enough to rewrite the beginning. And in 1979, during a solitary winter night of calculations, he found it. A note scribbled in his lab journal would later read, "Spectacular realization." That realization was cosmic inflation. It was not a slow push or a gentle swelling. It was a violent, exponential bloom. A fraction of a second after the Big Bang, the universe expanded faster than the speed of light, growing from subatomic size to cosmic scale in less than a heartbeat. Inflation didn't just stretch space, it ironed it out, it flattened it. It gave the universe the uniformity we see today, the smoothness, the balance, the structure. In Guth's words, it turned chaos into cosmos. At the heart of this process was a strange hypothetical energy field, the inflaton. Unlike gravity, which pulls, the inflaton pushed. Its energy density remained constant as space expanded, meaning more space meant more energy, and more energy meant faster expansion. A cosmic feedback loop, a runaway reaction. But this could not last forever. Eventually, like a wound spring snapping loose, the inflaton field decayed. Its potential energy transformed into particles, into light, into heat, the ingredients of stars and atoms. This moment, when inflation ended, was what we now call the hot Big Bang. Yet the deeper Guth and others explored this idea, the stranger it became. Because in the landscape of quantum fields, nothing decays uniformly. Some regions might stop inflating, while others continue. And those regions could bud off into separate pockets, entire universes, each with their own conditions, their own physics, sealed from the others by vast expanding walls of space. This was eternal inflation, a universe not as a singular event, but as a branching process, a cosmic foam of expanding bubbles endlessly blooming. Our universe, then, might just be one bubble in that infinite froth. And beyond the edge of our space, beyond the reach of any telescope, countless others inflate still, unconnected, unknowable. In this multiverse vision, some universes collapse instantly, others expand eternally in darkness. Some never birth matter, and a few might look hauntingly like our own. It's a vision both grand and disquieting, that the laws of physics, the very constants that define chemistry, light, life, might be local bylaws, not universal rules. That what we call reality is a regional dialect of a much vaster cosmic language. Guth did not set out to discover a multiverse. He only sought to solve the riddles of the early universe. But his equations whispered something more. That creation might be commonplace. That universes might be as plentiful as stars or grains of sand, each sealed in its own unreachable silence. The idea remains theoretical. Inflation itself is supported by observations, such as the uniformity of the cosmic microwave background and the distribution of galaxies. But eternal inflation, the bubbling multiverse, lies just beyond the edge of what we can test. Still, whispers echo. In satellite data, in quantum fluctuations, in mathematical models. Hints, not proofs. Shadows, not shapes. What began as a correction to a broken theory may have opened a door into something vaster than science had ever dared imagine. A reality not of one universe, but a multiverse. An eternal field of possibilities where our cosmos is just one blossom in an endless spring. If Guth is right, then the Big Bang was not the beginning. It was the local start of a much grander unfolding. A spark in a field that may still be igniting new worlds endlessly. And if universes can bloom forever, then what becomes of ours in the ocean of the infinite? Imagine space not as a void, but as an ocean. Not calm, not still, but frothing, infinite, and alive. Within it, bubbles rise, each one a universe unto itself, sealed in solitude, expanding into the nothing between somethings. This is the vision of eternal inflation, a cosmic mechanism not of one birth, but many. In this framework, universes are not singular events, they are inevitabilities. As Alan Guth's theory of inflation matured, it revealed something extraordinary. Inflation might never truly end. While our own universe settled into structure and starlight, other regions may still be inflating, driven by quantum randomness. Every fluctuation in the inflaton field, every stray pulse of vacuum energy could ignite its own bubble of spacetime, separated forever from ours. These are not stars in a sky or galaxies in a void. These are cosmic islands, expanding away from each other faster than light, cut off not by distance, but by the laws of reality itself. Time in one bubble may tick differently. The speed of light may vary. Gravity may have never existed. In some, atoms may never form. In others, life may burn with 1,000 unfamiliar colors. Together, they form the multiverse, not a parallel universe sitting beside ours, but a branching infinity where every pocket of space carries a different script. Our universe, then, may be one note in an eternal cosmic symphony. But if all other bubbles are unreachable, why believe they exist? Astronomers have long peered into the afterglow of creation, the cosmic microwave background, a faint wash of light left over from the Big Bang. It is the oldest photograph we can take, the universe's baby picture, frozen 380,000 years after birth. And in it, something curious lurks. A cold spot, a region where the CMB's temperature drops lower than expected. Not by much, just fractions of a degree, but far enough to raise questions. Some suggest it's a statistical fluke. Others whisper of bruises, the gravitational scars left behind when our bubble grazed another in the dark. Like soap bubbles colliding in a bath, such a cosmic contact would leave circular imprints, faint disks in the sky, subtle anomalies in the microwave background. Theoretical physicists have searched for these imprints, modeling their shape, their intensity. So far, the data is inconclusive, but the possibility lingers. And then there is the axis of evil, an eerie alignment of large-scale temperature fluctuations in the CMB. Instead of being randomly distributed as theory predicts, certain patterns stretch along a single axis, almost as if something nudged the early universe in a preferred direction. It defies symmetry, it unsettles the standard model, and it deepens the mystery. In search of explanations, some scientists look toward string theory, an ambitious attempt to unify all fundamental forces into a single framework. String theory doesn't just predict extra dimensions of space, it opens the door to an enormous array of possible universes. This is the landscape multiverse. Within the tangled mathematics of string theory, there exist over 10 to the 500 possible vacuum states, each with its own set of physical laws. Imagine a cosmic roulette wheel spinning endlessly, landing on a different configuration each time. Every spin births a new bubble universe, each one with a distinct version of physics, chemistry, even logic. Some universes could collapse instantly. Others might produce no matter, no light. But some, a rare few, might mirror ours, with galaxies, stars, and minds capable of asking why. Here, the multiverse is not a theory of abundance, but of necessity. Why does our universe seem so finely tuned for life? Why do the constants of nature fall within the narrow range that allows stars to burn and atoms to bond? In a multiverse, it's not surprising. Most bubbles are sterile. We happen to live in one where the settings are just right. Not because they were chosen, but because in an infinite lottery, even the rarest combinations must eventually appear. But this raises deeper questions. If there are infinite universes and infinite variations of laws, then there are also infinite versions of us. Not just similar planets or civilizations, but quantum echoes of our very selves. Some living parallel lives, others diverging in 1,000 small ways. This idea emerges from quantum mechanics, where particles exist in multiple states until measured, and decisions branch into probabilities. If each quantum outcome spawns a separate universe, then our lives are branches on an endlessly splitting tree. In one universe, a star never formed. In another, a child was never born. In yet another, someone watches the same stars, wondering the same questions, but speaks in a language our bubble has never known. This is the many worlds interpretation, where the multiverse is not born from cosmic inflation, but from quantum choice. And yet, the implications are the same. In a sea of infinities, what does identity mean? If there are copies of us, indistinguishable in thought, in memory, are we real? Or are we just statistical artifacts, flickering and in and out of temporary coherence? The philosopher's ghost returns in the form of the Boltzmann brain, a hypothetical consciousness arising from random fluctuations in a high-entropy universe. Given enough time, the argument goes, it's more likely for a single brain, with false memories and fabricated senses, to randomly appear than for an entire orderly universe to evolve naturally. It's a disturbing thought, that the universe we experience might not be one of stars and galaxies, but a transient hallucination in a thermodynamic haze. And yet, here we are. But even this bubble we call home may not last. The vacuum state of our universe, the field of energy that underpins all existence, may not be the most stable configuration. It could be a false vacuum, poised on a delicate plateau in the cosmic energy landscape. If it ever transitions to a lower, true vacuum state, triggered by a quantum fluctuation, it would unleash a bubble of destruction expanding at the speed of light. A vacuum decay, unstoppable, unnoticeable, erasing everything in its path: atoms, forces, time itself. There would be no warning, no pain, just nothing. This, too, is a consequence of the multiverse. If countless bubbles form, many will decay. Some collide, others rupture, and ours may be one of the rare stable ones. Or not. It may be that the fact we are here, asking these questions, is itself the only evidence we have that our bubble is still intact, for now. And in the spaces between these possibilities, the question deepens. Are we the rule or the exception? If consciousness can arise from so many roads, how do we know this version, this fragile bubble of reality, is the real one? We may be a cosmic anomaly, a low-probability event floating in a foam of more probable voids, a brief flicker of light in a sea of silence. The multiverse may never be proven. Its bubbles may remain forever hidden behind the cosmic horizon. And yet, the idea lingers, not as dogma, but as a whisper, a shape behind the veil. For now, all we have is this sky, these laws, this breath. But perhaps, just beyond the reach of our science, a neighboring bubble stirs, its own stars trembling, its own beings wondering if they are alone in the sea. If this is one of infinite realities, then who are we in the grand equation? Echoes, errors, or the first to ask the question aloud? And if our bubble is not stable, what happens when the silence begins to crack? There is a silence more absolute than the vacuum between galaxies. A silence that doesn't come from emptiness, but from the unraveling of existence itself. In physics, it is called vacuum decay, the possibility that the fabric of our universe is not built on the most stable foundation, that the vacuum we inhabit, the lowest energy state we know, might only appear to be stable, a plateau, not a valley, a temporary lull in a deeper storm. Imagine the universe as a delicate skin stretched across a landscape of energy. It rests now in a shallow dip, stable for a time. But deeper pockets exist, hidden below the terrain of physical law. And if a single point in space were to tunnel through, to drop into that truer vacuum, a bubble of annihilation would form. It would expand at the speed of light, not a flash, not a fireball, but a perfect edge slicing through space-time. Everything inside the bubble would be rewritten or erased. No signal would precede it. No alarm could outrun it. One moment galaxies, the next unmaking. The laws of physics as we know them gone. Atoms would cease to bind. Forces would no longer attract or repel. Time could collapse, or continue in a form we wouldn't recognize. And yet, there would be no pain, only the sudden cessation of everything. For now, this is only a possibility, a suggestion whispered by the Higgs field, which gives particles their mass, and may hint that our vacuum is not the bottom, but just a shelf in a much deeper canyon. It is a terrifying idea, but within that terror lies something oddly beautiful. Because if everything can be undone, if even the universe is fragile, then every moment becomes sacred, not because it lasts, but because it doesn't. To live in a temporary world is not to despair, it is to marvel. To wake each day under stars that may not always shine. To speak in a language that may never be spoken again. To wonder about things that may one day be unthinkable. In the sea of silent universes, most may never know light, or structure, or life. But this one does. Against impossible odds, this universe formed atoms, galaxies, rivers, minds. It formed us, beings capable of looking up and asking questions no other bubble may ever dare to ask. We are not guaranteed. We are not chosen. But we are here. And perhaps that is enough. Because to be temporary does not mean to be meaningless. A cherry blossom falls, a breath fades, a star burns out. But in their passing, something is revealed, something only fleeting things can show. The knowledge that even in its impermanence, this universe matters, precisely because it may not last. Maybe we are not the center of creation. Maybe we are not even common. But in this fragile, golden hour between birth and collapse, we are alive. We can speak. We can wonder. And maybe that is itself the spark, the one thing that transcends the bubble. Because to question the infinite, to whisper into the dark, to gaze beyond the stars not for answers but for awe, that is what it means to be aware inside a cosmos that may one day forget us. The multiverse may stretch endlessly. Other bubbles may exist, unseen, unreachable. Some may last forever. Others may flicker out before a single particle forms. But in this one, we ask the question: what lies beyond this breath of time? What came before the first light? What will remain after the last star folds into blackness? We may never know, but maybe that isn't the point. Maybe the asking is the purpose. Maybe the mystery is the gift. Maybe wonder is the echo that survives, even when the rest does not. Maybe we're not the center, but a question the universe keeps asking. One bubble in the cosmic breath, still trying to remember the sea.